So when you multiply rational expressions, it's very similar to simplifying rational expressions. It just means that you're going to have more than one fraction that you're multiplying together. So you're going to have two fractions. You could have three or four, but we really only deal with two. And so what we do when we multiply fractions is we just multiply straight across. So I'm just going to remind you guys how multiplying fractions works. Let's say we had the fraction 3/4 times 1/2. Whenever you multiply fractions, you just multiply the top two together and you multiply the bottom two together. So when you multiply fractions, you would just say, oh, this is 3 times 1 on the top and 4 times 2 on the bottom. You basically can just write it as one fraction with multiplication. And then you would say, oh, 3 times 1 is just 3 and 4 times 2 is 8. So it doesn't matter how many times you're multiplying different fractions. You can really just always write them as one fraction. Just put a multiplication sign in between. And so that's why this is going to feel like almost the exact same thing we did as yesterday, because we're still going to be looking at the tops and the bottoms and seeing what cancels. All we're going to do is we're going to cancel stuff out, and then we're going to get to the end, and anything that's left over in any of the tops of the fractions is going to end up on the top, because we had two tops here and it just ended up on the top. And anything that is left over in the bottom of the fractions is just going to end up on the bottom. So it's going to feel almost identical to what we did. So for our examples, the instructions are still going to be to simplify, but we're going to notice that the problems look a little bit different. So for this one, we're going to have 10 times 7x plus 3 divided by 9 times 9 over 10 times 7x plus 3. So we've got two fractions going on here. But we're going to do just like we did yesterday. So we're going to look at things that are the same on the top and the bottom, and we're going to cancel them. So I know that multiplying by 9 and dividing by 9, those two things cancel each other out. So I'm going to cancel the 9 with the 9. What else can I cancel? The what? Yeah, the parentheses, right? Those are identical. 7x plus 3, 7x plus 3. What else can I cancel? The tens. So when I cancel everything, it leaves a 1 behind. Because if you guys remember, if I grab my calculator and I type in 10 over 10, that doesn't leave a 0 behind, that leaves a 1 behind, okay? So anytime all the stuff cancels, that leaves me with 1. So this final answer is 1. Okay, let's try another one. So if we have 7 times n plus 7 over 7 multiplied by 5 times n minus 9 over n minus 6 times n plus 7. What do you guys see that would cancel? N plus 7. There's 1 on the top, 1 on the bottom. Okay. What else would cancel? The two 7s. 7, 7. Okay. Anything else? So at this point, there's nothing else that's identical, and so now we just leave anything that's left on the top, we stick on the top, anything that's left on the bottom, we stick on the bottom, and then we say we're done. So 5 n minus 9, n minus 6. And the bottom could have used the parentheses, or I could have not put the parentheses. It didn't really matter. So this is my final answer. So just like yesterday, we just have two fractions instead of one fraction. Okay, what is the same on the top and the bottom that we could cancel? V plus 7, 1 on the top, 1 on the bottom. V plus 2, 1 on the top, 1 on the bottom. V plus 1, 1 on the top, 1 on the bottom. Okay? So all the bottoms are gone. So if all the bottoms are gone, what's left over on the bottom? A 1, technically. So we would say this is V minus 4 on the top, 1 on the bottom. Anytime you have 1 on the bottom, it's kind of like having a whole number. And most people would not be like, oh, my answer is 5 over 1. Most people would be like, oh, my answer is 5. So once you've got only a 1 left over on the bottom, most people don't even put the bottom anymore. Most people just put the top. They would say, oh, I've got V minus 4 and I'm finished. I'm going to show you one where they got a little bit weird, because this can happen sometimes. It doesn't get too crazy, but they did a little bit. So we're going to do 5 on the top, 15 times n minus 3 on the bottom, 21n on the top, n minus 3, n plus 8. Okay. All right, what do you guys see? Anything that can cancel? N minus 3 is identical. Those can cancel. Anything with the GCFs? Mm-hmm. What do you guys think? The GCFs? Which one? 1 over 3. So 5 over 15 can become 1 over 3. So I'm going to take this away. I'm going to make it be 1 over 3. Okay? Anything else? Not the n, because this n is actually in a parenthesis, right? Okay, so we can't do the n. What about the... Yeah, so we can deal with the 21 though, right? Because 21 and 3, what would that be? That'd be 7. And if we were to write it as a fraction, where would the 7 go? Top or bottom? Top. And what would go on the bottom? A 1. Okay, so the 21 over 3 is going to become a 7 over 1. 21 over 3 becomes a 7 over 1. Does that make sense? So we actually ended up that this number got simplified twice with two different numbers. So the 5 over 15 got simplified once, and then the 21 and the 3 got simplified. And that's okay. Sometimes that happens. So this became 7 over 1. Okay, so 1 over 1, I don't really have to write those. 1 times 7 is still just going to be 7. So I can multiply it out, but it's not really going to help me much. So what do we have on the top? What's left over on the top? 7 and an n, right? So 7n. What's left over on the bottom? N plus 3. Perfect. So 7n on the top, n plus 3 on the bottom. Okay. So that's what they look like when they factored them for you, but we're probably going to have some problems where we have to do the factoring ourselves. So let's look at a couple of those. And these problems where you have to factor yourself, it feels like it's like, I don't know, 6 problems in one, because you have to factor a bunch of stuff, and then after you factor a bunch of stuff, then you actually start the problem. So we've got 3 trinomials in here. And for the trinomials, we do the x thing, right? So we're looking for something that multiplies to negative 45, but adds to 4. And we're looking for something that multiplies to negative 7, but adds to 6. And we're looking for something that multiplies to 63 and adds to 16. This one is what? Okay, negative 5 and 9. Positive 7, negative 1. Seven and 9. Okay. So we've got x minus 5, x plus 9 over x plus 5, x plus 7, x minus 1, x plus 7, x plus 9. Okay. So what do you guys notice? X plus 7s cancel. X plus 9s cancel. I want these to cancel so bad, but do they? Nope, they're not identical. They're the wrong sign. Okay, so what is our final answer? What do we have on the top? X minus 5 and? Okay, x minus 5, x minus 1. And then what do we have on the bottom? X plus 5. Done. Isn't it so much fun when you guys have to factor? No? You don't think that's fun? That's not your idea of a good Tuesday? A nice, enjoyable Tuesday? You're not like, oh, thank goodness we had time in the school year to get to this unit so we could do this factoring yet again? It's easy? Well, that's a good sign. We like that. Okay, let's do one more, and then I'll give you guys the worksheet. Destiny just flopped her head down on her desk in sheer happiness. Okay. So we've got trinomials. Those are where we do the x thing, right? And then we've got these binomials. What type of factoring are these? GCF. Okay. So we've got two where we're going to say we're looking for what multiplies to negative 10 and adds to 3. We're looking for what multiplies to negative 12 and adds to 4. Okay, wait, 5 and negative 3 you said? Negative 2, okay. And then this one is multiply to negative 12, add to 4. 6, negative 2, okay. And then, okay, so let me write these. So v plus 5, v minus 2, v plus 6, v minus 2. Okay. Any idea what the GCF is right here? 6. So 2 is a common factor, it's just not the biggest one. So 6 is the greatest common factor. And what's left over when you take out 6? V and 36 divided by 6? 6. And what's the GCF down here? 3. And then what's left over? V 5. Okay. So what cancels? V plus 5, one on top, one on bottom. V minus 2 and V plus 6. 6 over 3 becomes 2. 2 over 1. And 2 over 1 is actually just 2. Ta-da! That's my favorite. I love when a bunch of stuff cancels out. Okay, so I'm going to go ahead and give you guys your practice worksheet, which has a whole lot of problems where it's already factored. And then, so what I did is the front page is completely factored for you. 1 through 10, every single problem is all the way factored. On the back, I gave you problems where they're a little bit factored, but a little bit not factored. So you might have to factor a little bit in the problem to be able to do it. And then I only gave you 2 problems where you like completely had to factor yourself. Okay? All right, tried to make it not so painful for you guys.